In statistics, we have variables, which are simply just characteristics that we can measure. But when we do measure them, that creates data. We can classify data using a level of measurement. There are 4 levels of measurement. They are nominal, ordinal, interval, and ratio. As the data moves this way, in terms of these 4 levels of measurement, we have more statistical procedures at our disposal in order to analyze the data, which is why it's good to know what level of measurement the data is. So just to be clear, if we are on this end, if we have nominal data, then that means we are limited in our analysis of the data. We have very few statistical procedures at our disposal to analyze that data. Whereas if we're at the ratio end, then we have a very full grouping of procedures that will allow us to analyze the data. So what exactly are these levels of measurement? Well, first, the first 2 levels of measurement, nominal and ordinal, are going to be qualitative data, and the last 2 are going to be quantitative data. So basically, the first thing you want to do when you see a problem that's asking you for the level of measurement, you want to look at whether it's qualitative or quantitative data, because if it's qualitative, then you're limited to just being a nominal or ordinal level of measurement, and if it's quantitative, you're limited to being interval and ratio. Again, this is the first thing you want to do in any data type problem where you're asked for the level of measurement. Okay, so let's say you have a qualitative variable that's producing data. You are asked for the level of measurement, and you now know that that must be nominal or ordinal, but of course, you have to decide which one it is. Let's talk about that. So I have 2 examples down here, one each of nominal and ordinal. So let's talk about nominal first. So nominal data, a good example of a variable that produces it would be political party affiliation. So for example, whether you're Democrat, Republican, Independent, etc., etc. We'll just go with the main 3 for now. So when you look at the results over here of the variable political affiliation, you'll notice that there is no ranking to the results, meaning whether you're Democrat, Republican, or Independent, one is not rated higher than another. I know some might have a different opinion of that, but generally, like in the world of data, one is not necessarily higher than the other. As a matter of fact, even if we assigned a number to these for the purposes of analyzing the data, it doesn't mean that number 1 is greater than number 2 or better than number 2. It just in this scenario means there's no order. So why do I keep on mentioning order? Because for ordinal data, which is our next example, it's going to be the opposite. So one example of that would be satisfaction level. So a lot of times if you go to the doctor or among many other things, you often get surveys sent to you about your satisfaction level with the service, something like that. So let's talk about a very simple scale here of 5 different categories of satisfaction level. We have very unsatisfied, unsatisfied, neutral, satisfied, very satisfied. So what is different about this specific variable satisfaction level is that these actually do have an order to them. So a lot of times, actually, what you'll see is you'll have a number attached to each one of the satisfaction levels, and clearly a number of 1 represents something that's less than a number of 5, meaning you're less satisfied. So That is literally the only difference between a nominal and ordinal type data, is that you're going to end up with some order when it comes to the ordinal type value. So you want to make sure that you see the difference. So just to be clear, if you're given a problem where you're asked to identify the level of measurement and you've already determined that it's qualitative, then you're going to look at your data, the results of your data and your variable, and you're going to see if there's any order to the results. If there is order, then it is ordinal type data. If there is no order, then it is nominal data. Okay, so let's tackle the other two levels of measurement. So again, if you're asked for a level of measurement for your data and you determine that it's quantitative data, that means you have two options. It could be either an interval or ratio level of measurement. Okay, let's look at some examples of interval and ratio. We'll start with interval. We're going to use temperature, which is a very famous interval level of measurement, and we'll use Fahrenheit. It wouldn't matter which one we use, but since we're comfortable with Fahrenheit, I just basically just show, just so that I'm consistent with what's up here, I just put the possibilities down here so you kind of had an idea of consistency. If you look at the numbers, basically the lowest measure ever is negative 128 degrees Fahrenheit, which I think was in Antarctica. The highest, which is in some desert somewhere, was 134 degrees. And you basically, any number in between is okay as a temperature, right? Or has been a temperature that we have seen. Even though we know that temperature is quantitative and ordinal, let's say up here, is qualitative, one thing to take note of is the technical reason why interval separates itself from ordinal has to do with subtraction of its values. I'll give you an example. So like if you subtract neutral from unsatisfied, how do you even do that, first of all? But let's say you did. There's no really knowledge of the fact that the difference between these two values is the same as the difference between these two values. We can't quantify that. We can't find a difference between consecutive values. But if you go to, let's say, Fahrenheit temperatures, then we could say, okay, well, the difference between 0 and 50 is the same as the difference between 50 and 100, or something similar within it. So there is a consistent difference between certain values within an interval, as opposed to in an ordinal, there just really doesn't exist. We don't know the difference between these consecutive values, where we can do that when we're dealing with temperature. Honestly, I don't know if we'd use that much when we're actually doing example problems, but it's something worth noting. Now, the key element to what's going to determine the difference between interval and ratio is that when in interval examples, your 0 value usually doesn't represent something significant. So what do I mean by that? So for instance, in temperature, no matter whether you're on the Fahrenheit or Celsius scale, 0 doesn't represent the bottom, or in other words, true 0. You'll notice that there are plenty of values that can go below 0. So that's one instance when 0 doesn't represent something significant. Another one would be, let's say, let's do SAT scores. So as you know, in SAT scores, you can't get a 0 as a score. I think the lowest one, I think it might range from like 400 to, I'm just going to say, I think it's 1600 or something like that. So there's no true 0 that means anything in this. The bottom is not 0. So the key, which is again going to distinguish between these variables, is that when you have an interval level of measurement, you're going to have quantitative data, but the 0 is not going to mean anything relevant to what you're doing. Okay, so ratio. A ratio level of measurement, a good example would be weight. So if you look at the weight of something, I did do a human, and the largest human ever was 1400, which I was astonished by, but that's a different story. But just generally, weight of anything scales from anywhere from 0 to whatever the weight of the object is, right? So you'll notice that again, though, the difference between 50 and 100 and 150 is consistent. So if I weigh 150, another person weighs 100, they're 50 pounds heavier. Same thing if it's 150, 50 pounds heavier, right? It could be a person, it could be an object, whatever it is. But the key is again this value here. In a ratio level of measurement, what separates it from an interval, because ratio has all the traits of interval, is that zero is relevant. It is a true zero. You cannot have a negative weight, and zero represents the bottom of what you're dealing with. That's the lowest amount that you can have. Another example, let's say, would be length. So the length of an object. If it has no length, it is zero. It is the bottom value. You can't have negative length. So that's going to be the key element when deciphering between interval and ratio. So again, let's say you're asked for a level of measurement. You determine that you are dealing with a quantitative variable. If it is quantitative, then you have two options, interval or ratio. You're going to look at the values. You're going to determine, the only thing you have to figure out is whether there is a true zero value that means something. If it is, then it is a ratio level of measurement. If it isn't, then it is interval. I'm going to be honest, this entire topic can be challenging for students, especially if you overlook some of the definitions and things that they might give you in the textbook or even when you look it up online. But if you follow my lead with this, this can be very straightforward by just using these two key elements right here in order to determine whether it's going to be nominal versus ordinal or interval versus ratio after determining whether it's qualitative or quantitative. Okay, so let's do some examples just to get this straightened out. So to be clear, our goal is to determine whether the following variables would produce data that is a nominal, ordinal, interval, or ratio level of measurement. Okay, our first variable here is letter grades in school. Okay, so what are we dealing with? We're dealing with basically A, B, C, D, F. There could be plus grades like we have at RV. It doesn't really matter. The key, though, is that when you look at this, the first thing you want to determine is if it's going to be qualitative or quantitative data. Clearly, we're dealing with qualitative data. Okay, we're dealing with letter grades. So once we know that it's qualitative, then we're going to determine whether we're dealing with nominal or ordinal data. So we want to look at this and go, if I was to label this with numbers, let's say we did 1, 2, 3, 4, 5. Would 1 be bigger than 5, less than 5? Does the order matter to this? Remember, that was the key. Remember, I put a star right here. Does the order matter? And if you look at this very closely, order does matter because an A grade is bigger than a B grade, which is bigger than a C grade, and so forth, which means we're clearly going to be dealing with ordinal data, an ordinal level of measurement. So again, it's very simple. We don't have to get into crazy definitions. We just have to know ordinal versus nominal. We just have to check the order. That's it. If it's ordered, that means we're dealing with ordinal. If it's not, we're dealing with nominal. Okay, what about distance to the nearest pizza place? Okay, so distance in general is a quantitative variable, which means that we're dealing with interval versus ratio. Remember, the only thing we care about to determine the difference between whether it's interval and ratio is whether there is a true zero. So my question is, could the distance to the nearest pizza place be 0? I know that my wife in college lived over a pizza place, which means her distance to the pizza place was 0. I know that sounds crazy, but that is where she lived in college. So I had an off-site apartment. So in this scenario, there is a true 0. Can you have negative distance? Absolutely not, which means 0 represents the absolute bottom of this quantitative variable, which means if that's the case, then we have a ratio level of measurement. Okay, what about colors of crayons in a box? So colors of crayons in a box, what would that look like? That would be, let's say, green, yellow, red, whatever it's going to be. I can just put a bunch of green, yellow, red, blue, etc., etc. Lots of colors, right? Now, if I were to put numbers on these colors, like 1, 2, 3, whatever it is, again, etc., would these numbers represent order of some kind? So is green on top of yellow, which is on top of red, or in some order? When you look at that, my hope is you look at that and say, no, I mean, well, how is blue bigger than yellow, which is bigger than... There is no order to the colors in a crayon, which means if that's the case, order meant ordinal, which means our only other option here is nominal, which means this is a nominal level of measurement. Okay, what about time of day on a watch? Well, if you think about it, if you watch, let's say we're just doing a digital watch, right? It's clearly a quantitative variable. Now we're dealing with a numeric here. So that means we're dealing with interval with ratio. Our goal is obviously we just need to determine whether there's a zero, and can you have a time of 0 on your watch? You can't, which means we immediately know that this is a interval level of measurement. What about income in dollars? Again, quantitative, which means we are interval versus ratio. Can we have 0 income in dollars? I don't think anybody wants that, but absolutely you can have 0 income in dollars. That would be if you don't have a job and you got no money coming in, which means there is an absolute 0, which means it has to be a ratio level of measurement.